Good afternoon. Once again, welcome to the afternoon session of Impact Lecture Series organized by IIC St.Thomas College, Palai, sponsored by Ministry of Education's Innovation Cell and AICT. Thank you for sticking to the time. Let's begin the session by a silent prayer and seeking the grace of God. I would like to welcome Dr. Ruby John Anto, Scientist Division of Cancer Research, Rajiv Gandhi Center for Biotechnology, Thiruvananthapuram. Dr. Jayesh Anthony, Assistant Professor, Department of Zoology, Ms. Rajeshwari R. Menon, Research Scholar of Department of Commerce, IIC officials, other teachers, and all the participants to this online Impact Lecture Series wholeheartedly. It's my honor to welcome Dr. Jayesh Anthony, Assistant Professor, Department of Zoology, for framing words of welcome to the research person.
A very good afternoon to all. Am I audible?
Yes, sir.
Okay. It's my privilege and pleasure to welcome and introduce our Chief Guest and Resource Person, Dr. Ruby John Anto. It's really tough to introduce her in short time, but I will try to convey her major achievements in brief. Dr. Ruby John Anto is currently working as Scientist G in the Cancer Research Division of Rajiv Gandhi Center for Biotechnology, a leading national research institute under the Department of Biotechnology, Government of India. After acquiring her PhD in biochemistry from Amala Cancer Research Center, Thrissur, in 1995, she joined in RGCB as a research associate. Later, she moved to MD Anderson Cancer Center, Texas, USA, as a visiting scientist. After she joined in RGCB in 2000 as Scientist C. During her research career, she has received several awards, of which the most prestigious one was the Young National Woman Bioscientist Award from DBT in 2005. In 2016, she has elected as Fellow of National Academy of Science, India, and followed by Fellow of Kerala Academy of Science in 2017. Her PhD students and postdoctoral fellows has bagged 30 presentation awards in various national and international conferences, all of which proved her dedication and excellency in research. She has patented several of her findings, of which the most promising discovery was an anti-cancer compound against hepatocellular carcinoma. Today, she will be talking on the story of discovery of this compound and how this product is patented and commercialized. These findings received several international patents from US, Canada, Japan, and South Korea. Now this product has taken up by Oklahoma Medical Research Foundation, USA, and the multinational pharma company Q Biomed for commercialization. In January 2021, this compound is recognized as an orphan drug. She has produced 11 PhDs so far, and 3 more are in the pipeline. She has published 5 international book chapters, 68 research papers in various reputed international journals, and 17 non-peer-reviewed publications. She has successfully completed 15 research projects funded by various national and international funding agencies, and 4 more are ongoing. She has membership in several reputed organizations like American Association of Cancer Research, American Society for Biochemistry and Molecular Biology. She is serving as editor in different reputed journals like PLOS ONE and Science Letters. She has reviewership in around 14 international journals, as well as in funding agencies like DBT, DST, CSIR, ICMR, and STEC. She has organized 6 international seminars, delivered 6 international talks, and around 34 invited lectures in various parts of the country. Of course, many more are in the list, but due to lack of time, I am concluding here. I would like to add one more point is that she was the research guide and mentor for my PhD, and she is still continuing her mentorship in my research career. Thank you, madam, and I welcome you for the presentation. Over to you, ma'am.
So, can you hear me?
Yes.
Okay. So, thank you, Jayesh, for the invitation and the good words about me. Thank you very much. And I am very proud to say that Jayesh was one of the pillar stones of my lab. Okay. And as the title says, bioprospecting of novel innovations. Actually, it was Jayesh who started the bioprospecting in my lab. Before that, I have worked on natural products, but all were already established and commercially available. And Jayesh was the first person to isolate a compound in our lab, and including him, 4 students took PhD on that compound. So, yeah, and I was very sad when he got the selection in the college in Pala St.Thomas, because I knew that he was an expert in several techniques, and he has standardized several techniques in my lab, and he won't be using those in the college. I was sad that you know, so many techniques I taught him won't be used anymore like that. But now I am happy in one way that he is giving motivation to so many students, the new generation. In that way, I am very happy also. So, bioprospecting is defined as it is a systematic and organized search for novel molecules which are useful in science and which can lead to the commercialization and the benefit of the society. And the major focus of my lab is bioprospecting for chemotherapeutics. That means compounds which can be used as drugs for cancer treatment. And chemosensitizers, that means which can improve the efficacy of chemotherapy, and chemopreventives, that means which can prevent cancer from occurring. So these are using different techniques. We are trying to evaluate different compounds which have any of these properties. So these are some of the compounds which are well known for as natural chemopreventives, some of the plants. And in our lab, these are the compounds studied in our lab. And curcumin is the most studied compound in our lab. And curcumin has been evaluated as a chemosensitizer and chemopreventive. And this is the compound isolated by tryptanthrene. Isolated by Jayesh. The name of the compound is tryptanthrene. And this is the compound he mentioned about it is utroside B. This was also a compound isolated in our lab. Camphoride was another compound. These were the 3 compounds isolated in our lab. So, as remedies for cancer, the first thing is prevention itself. Better not to get the disease. It is always better. And if it has already come, then we have to go for the therapy. So the prevention of cancer, occurrence of cancer can be prevented either by chemoprevention. That means compounds which can block the cancer, the development of cancer or the progression of cancer in any stage of its progression. Chemotherapy means the treatment of cancer using drugs, and change in lifestyle means if you are keeping yourself away from some of the cancer causative agents, that also a way of prevention. And in chemo prevention, there are the cancer progression occurs in different well-defined steps. But first is initiation, second is promotion, and third is progression. So if a compound, or if you can block the initiation stage, that is primary prevention. And if you can block the promotion stage, it is secondary prevention. If you can block the progression stage, that means just because it is initiated, you cannot get cancer. But initiation is a irreversible step. You cannot reverse the initiation. Once it is initiated, it is initiated. Okay. Then promotion, this is a reversible step. Okay. This is just a mutated cell. All the cancers occurs due to mutation occurring to the DNA. So the mutated cells, when given opportunity, it will be promoted to a group of tumors, which again, due to some other factors within the body, they will be progressed, and they will enter our lymphatic system or blood system to move to distant organs in our body. That is the progression step. It is then after, when it is the process is called metastasis, and when it is metastasized, it is difficult to treat cancer. And chemotherapy, as I told, it is the treatment of cancer using chemicals, and depending upon their mechanism of action, they have been named as different, alkylating agents, antimetabolites. That is depending upon the mechanism of action of the drug. So when a compound is used as a chemotherapeutic drug, the most important hurdle for the chemotherapy is its attainment of resistance. The compound, the cancer cells becomes resistant to that drug, and they do not respond to the drug anymore. So this is cancer stem cell like cells. So then they become a resistant. If a drug is killing all the cells, one person is escaping, and that cell will progress and to become a big tumor. Then it is become the recurrence. It is the reason for the recurrence of the tumor. So we cannot reduce the concentration of chemotherapy. Okay, we know the chemotherapy causes different side effects. So it will, by the reason for the side effects is that almost all chemotherapeutic drugs are targeting rapidly proliferating cells. Okay, so these cells will be killed by the chemotherapeutic drug, but there are several normal cells in our body which also divide very fast. For example, the cells of our hair follicle, the cells of our digestive tract, etc., also will divide very fast. So when you give a chemotherapeutic drug, these cells also will die. So the person becomes unable to eat food, even take water, and there will be a severe hair loss. So these are side effects. So in that case, we may feel that okay, we will reduce the concentration of the drug being used as treatment. But if you reduce the concentration, this is the problem. You will get a chemo resistance, and the cancer will not respond to your drug anymore. So chemo resistance is the major problem in chemotherapy. So it is in this scenario we thought of trying some compounds, natural products which are non-toxic as chemosensitizer. That means this chemosensitization is a phenomenon at which it is the action of one drug will be enhanced by the presence of a compound, which is either synthetic or natural, but it will be non-toxic. Okay, so that compound may not be that effective alone in killing cancer cells, but when they are used along with this conventional drugs, it will heighten the cancer cells vulnerability to the other drugs. The examples are curcumin, resveratrol, EGCG, gingerol, green tea, etc. They themselves have been shown to have cytotoxic effect to cancer cells, but not cannot act as a single chemotherapeutic drug. So what they can do is they can reduce the survival signals induced by these conventional drugs and enhance its chemotherapeutic potential. Okay, so our lab is primarily focusing on identification of the compounds which have chemotherapeutic, chemopreventive, or chemosensitizing efficacy. So for identification, what we are doing is we shade dry the compound, the plant product, and then do a successive extraction using different solvents of varying increasing polarity. Then we check the activity of the compound, that extract, in cell cultures. Then we identify the compound. If the compound, for example, this is control, this is untreated control, this is treated with that extract. If there is a cell death, that means it is a probable compound extract to be identified for a compound. And definitely, if you put potassium cyanide also, this will happen. So we should make sure that this extract is non-toxic. So we have to repeat the experiment in the normal counterparts, okay, of the cells. Then after getting the isolating the compound, we will go for tumor reduction studies in animals. So there is a rejection. If you use normal mice for developing a tumor, a human tumor, it will reject that mice body will reject it. So we are using immunocompromised mice for doing our animal experiments. Then the cancer cells will grow, and then we treat our after developing the tumor, we give the drug also. Then if there is a tumor reduction, this is a control, this is a reduced tumor. Okay, so this is the difference. So there will be tumor reduction. That means that our compound is a potent drug to be evaluated. This is the difference in the tumor volume between the control and treated animals. Then if it is very effective in animals, then go for clinical trials, safety. First go for safety trials, then for phase 1, phase 2, phase 3 evaluation of the drug. Then it will be taken by some companies. It will be difficult for us to do the clinical trial because it is a lot of money. For the clinical trial, there will be all the drugs should be provided free of cost, and we don't have that much money to make that much drug. Okay, and the people should be given everything free of cost, and it is lot of time and money consuming. So it can be manufactured by companies only and marketed also. And coming back to our curcumin, she is my first student. She is now assistant professor in Calicut University. So she found that curcumin can act as a chemosensitizer for cervical cancer treatment. Paclitaxel was the chemotherapeutic drug used, but when we use the combination with curcumin, we can see a severe, very, very good tumor reduction. And this finding was also patented, and he followed up. This is Srikanth. He's in US now as a postdoc. So he did the animal experiment part. This work was done by Srikanth. Smita did the in vitro analysis, and Srikanth did the in vivo evaluation of this combination. In vivo means within the body. That means in animals. This is the cervical tumor developed, and when you treat with the drug, you can see the combination. The tumor size is very less. This drug was that this was also published in Oncogene. And the problem with curcumin always is its solubility. It is insoluble in aqueous media. You can see the curcumin sedimented. So curcumin, if you put 25 micromolar curcumin in any cell, any in vitro culture, all the cells, any cancer cells will die. But then why we cannot use it as a drug? The problem is, however, quantity of curcumin is administered in vivo, only the serum concentration will be less than or around 5 micromolar. So there is no meaning in using 25 micromolar. Okay, so that's why we evaluated curcumin as a chemosensitizer. In all the previous studies, we have used 5 micromolar curcumin to sensitize. Okay, so we did a nano encapsulation. Here we used, curcumin. When for all the in vitro studies, we can dissolve curcumin in DMSO. This is DMSO dissolved curcumin. It is completely soluble. This is a water added curcumin. It is completely sedimented. And we made one with Dr. Vinod Kumar from RGCB. He made the nano formulations of this curcumin, and we found that it is become aqueous dispersible. And we found that the efficacy of that combination is increased. You can see the combination has the tumor size is further reduced. And we also checked whether curcumin can use as a chemo preventive against benzopirin-induced lung carcinogenesis. Benzopirin is a carcinogen present in deep fried food and cigarette smoke. Okay, so even though the smoking habit of people are decreasing nowadays, the lung cancer incidence is increasing. The reason is this deep fried food. That means our fast food culture. So we checked whether curcumin can prevent the benzopirin-induced lung carcinogenesis. And we found that it is very effective. And when you use the nano encapsulated curcumin, the efficacy was further increased. Then we checked whether curcumin can as in cervical cancer, whether curcumin can chemosensitize breast cancer cells to 5-fluorouracil. Okay, that is a drug used for triple negative breast cancer treatment, because triple negative breast cancer cannot be used for, triple negative means some cancers are, breast cancer occurs due to the estrogen receptor overexpression, some due to HER2 overexpression, some due to progesterone receptor overexpression. So these type of cancer, breast cancers, can be treated using their targeted therapy. Okay. For example, estrogen tamoxifen can be used as a like that. HER2 can be used. Herceptin, it is an antibody against HER2 overexpressing cells. So, but in the case of a triple negative breast cancer, you cannot treat any of with this cancer with any of these molecules. So, but we in that case, 5-fluorouracil is one of the drugs used for triple negative breast cancer. 5-fluorouracil can be used for treating other cancers also. I mean, colon cancer, etc. So, we checked whether curcumin can sensitize breast cancer cells to 5-FU, and we found that it is very well sensitizing breast cancer cells to the 5-FU treatment. And this is another tumor model. This is a chemical carcinogen induced tumor model. Here we are inducing the breast cancer using DMBA, and we found that you can see the reduced size in the combination. And resveratrol, it is a compound from the isolated from the skin of the um, grapes, and there are in some other berries also this compound is present. So it is a very good compound, but we found that here the sensitization is in HER2 overexpressing breast cancers, not triple negative. And this is another compound, heteronamine. This is a compound isolated from marine sponges. It's not, we did not isolate it. It was isolated from other group, and we bought it commercially. And this compound was found to be very effective in sensitizing the acute myeloid leukemia cells towards cytarabine. So I told you our focus is bioprospecting, and we were doing the evaluate by it was extra there are the while we were doing the experiments with the curcumin, resveratrol, etc. Side by side, we were doing some extramural projects. Okay, so from in those projects, we evaluated this plant variety tinctoria, Chromalina odorata, and solanine. All these were extramural projects supported by CSIR, ICMR, etc. And Jayesh was taken to this project, right here tinctoria. It was a CSIR funded project. Actually, till that time, I had not started the isolation in my lab. Everything was purchased from the companies, all the other compounds, the resveratrol, curcumin, etc. So when I wanted to isolate this compound, so while during the interview, I was telling that I want a person who is expert in chemistry. Okay, the purification part. You have to get a compound from this part, this plant. So we will look for a person who is who has at least some chemistry background. So we were doing the interview. There so many people came, and Jayesh was performing very well. And he got 98 point from his MSc mark. When the other scientists also were there in the interview. So I had told these people, we have to get a person with chemistry background. So we were asking, so MSc mark 98.5 something like that. So by joke they asked, what happened to that 1.5% mark? So he was trying to, I lost 2.2% like that. Everybody was laughing. But we asked whether, do you have chemistry background? Even for his BSc, he has not studied chemistry, he told. Okay, then I was very upset. How I will take this boy? I think his BSc, zoology, botany. What the other subject, Jayesh?
That is aquaculture, fisheries.
Yeah,
Fisheries.
so yeah. So it was, I was very much worried, and he was very nicely performing also. So but he was very confident. I asked him, can you do this work? Can you isolate a compound from this plant? So he told, madam, I was not knowing anything when I joined for BSc, but I studied everything. And MSc, when I joined, but I studied everything. So if you teach me, I will learn this also. And the other scientist also was telling, yeah, he's right. That's why he got this much mark. Let us take him. That's how I took him, and I promised him that if you pass the CSIR, get the fellowship, I will make sure that you will do PhD under my guidance. And I kept that word. I took him as a PhD student, and definitely it was very tough for him, very, very tough for him, but he did it with the help of one of our collaborators. He isolated the compound tryptandrine, and 3 other students did PhD on the same compound. So I am very proud that, and some other work also, I told him that breast cancer work also, someone got job, and I told him to continue. He never told I cannot do that. That also he did simultaneously. I think he is equal first author in that paper also. So, when there is a will, there is a way. if you are really willing to do something, you can do that, even if you don't have a background experience. And moreover, in the lab, it was in our lab. He made an arrangement to my lab. The name of the minus 70 chemicals, minus 20 chemicals, fridge chemicals, with the help of Harida, another PhD student, his junior. He made a systematic list of everything in our lab. Even now, we are following that. So I'm very proud that, and I'm very happy that he will be doing the same thing in your the college also. I think it is he is an asset to any college, any institution. So these were the three compounds isolated in our lab. The first thing was tryptandrin. Then this the other was chromalina from odorata. We got the compound camphoride, and from solanum nigrum, we isolated our star molecule, utroside B. So this from the Lakshmi, actually she was also she had a pharmacology background, and when she joined my lab, she was not biotechnology. So I told her I don't have that much expert anyway. Jayesh is working here, but still he himself was struggling to get his compound, so maybe it will be difficult. But she was very confident that she can do that. She will identify the compound, and she tried several molecules, several plants, and she could not get. So there were two, in the background of my house, backyard of my house, there was this plant. Chromalina odorata was growing like a forest. I don't see that now in my in that place, but I took those things to her, and the other plant also. It was in my terrace, so that also I gave her. She isolated two compounds from both these plants. So this compound camphoride was found to be very effective against cervical cancer, and tryptandrin. This Jayesh isolated this compound. And Meenakshi also was there along with him, his junior. So this compound was found to be very effective. Before tryptandrin, he isolated this fraction DWFI. It was found to be very effective against malignant melanoma. Actually, this compound also we could have patented. Okay, at that time we were thinking that when a compound is already known, it cannot be patented. But actually, this property, it was Jayesh who found that it is more this efficacy of this compound in melanoma. We could have done that as a we could have patented as an anti-melanoma drug, but before that he had kept his thesis, submitted his thesis. So, anything published, thesis also is known as a publication. So we cannot do that, and that is what happened. Otherwise, this was also a fantastic research, uh, a drug identified in our lab, and we could not do the patent. Okay, we were not aware of that much about the patent possibilities as we are now. So you can see that this is the control. Tumor developed. The drug is very effective against malignant melanoma. And we found that the Shabna, his junior, followed the work, and she found the mechanism of action of the compound. And we found that the compound is, depend mitefm. Mitefm is a this molecule is known as the master regulator of melanoma progression. So we found that this compound is, when you overexpress MITF, the compound becomes this is the IC50 dose corresponding to IC50. We can see here if MITF is not overexpressed, there is tumor reduction. But when MITF is overexpressed, there is no tumor reduction, even up to 4 times the IC50 concentration. Then here it is the IC50, from 3, you can see here, from 3 it comes to 15. Okay, when the MITF is overexpressed. At that concentration, tryptandrin is downregulating the expression of MITF. So this work is now under minor revision from cellular and molecular life science. Jayesh, these three people are equal first authors. All these three are equal first authors in this paper. I hope it will be accepted very soon. Then we checked whether tryptandrin, the Meenakshi followed that work. She found that this when tryptandrin is used along with the dacarbazine, a compound used for the currently being used, okay, for the treatment of melanoma. So when you use the combination, okay, that means it is, we are always in the chemosensitization work, we always use a non-toxic or subtoxic concentration. Okay, it's not like the cytotoxic concentration. Okay, so for example, when we use the IC50 concentration of tryptandrin is 3, so here we use 2 micromolar, like that. So, but we can see it is the MITF is completely downregulated by this combination, and you can see the images. This is the tumor. The tumor cells were transfected with the Luke, so we can see the fluorescence here. But in here in the combination there is no fluorescence. Okay, that is the tumor reduction. And Mohan checked whether this compound can prevent the non-melanoma skin cancer. All the others were melanoma. This is non-melanoma skin cancer is the most important, the largest, number of the people having non-melanoma skin cancer, even though it is not a fatal disease. Okay, so especially in foreign countries, it is a very big problem, and 1/3 of the people are having this non-melanoma skin cancer. So we found that you see this is the control non-melanoma skin cancer developed by DMBA and PMA. It's a carcinogen, and this is a multi-stage. This is the initiator, this is the promoter, and we can see that it significantly prevents the tumor occurrence. And this is the mechanism by inhibiting the beta-catenin signaling. Now comes to our star compound, utroside B. I told you, Lakshmi identified this compound. It was not very easy. It was very difficult because it is such a big molecule. This is it is 1200 something with the molecular weight. Our collaborator, Dr. L. Ravishankar from NIST, actually he came to us as a, like an angel maybe, because in the till the last year of her PhD, she could do all the anti-cancer work. We found that it is very, IC50 of the compound is 500 nanomolar. So it is a very potent molecule, but we were unable to identify the molecule at the time. This time only he came to me to get some cytotoxicity work done on his compound identified in his lab. So I told him, definitely I will do that, but can you identify this molecule? So he took it as a prestige issue, and he did that for us. So that's how the whole story started. So you can see we checked the activity of the compound in different cancers, and we found that HG2 is liver cancer. It is very sensitive against liver cancer. You can see the IC50 in other cancers also. It is effective for other cancers also, but it is in liver cancer, it is very effective, 500 nanomolar. So you can see the tumor reduction in the treated group. And it is inducing apoptosis, tumor size reduction. In, when Lakshmi did this experiment, it was 10 animals we had taken, but only in 4 animals we got at least visible tumors. Okay, in other animals there was no tumor developed at all in the treatment group. So we patented, as Jayesh told, this compound was patented in US, Canada, and South Korea, Japan, etc. etc. So and in other countries also it is getting, it is being processed. And this compound was transferred. Actually, I told you a lot of money is needed to do the clinical trial. When so many people ask me why you transferred this compound to a company, an American company, because if I don't do that, I am retiring next year. So if I don't do that, this compound will die with me, right? Nobody is going to follow up on this compound. So I thought, instead of keeping it to myself, if somebody can do that, okay, even after me, it will become a drug. Okay, so and it has the potential. So these people approached and we transferred we commercialized. Of course, our institute was uh, granted money. In each stages, they will be transferring the money to our institute. Definitely, a part will come to me and the student also. And most interesting thing is the US FDA approved this as an orphan drug against the liver cancer. So that is also very happy thing that, and we found it is a drug. Liver cancer we currently don't have much options to treat. Okay, only sorafenib is one of the drugs used. There are some 2-3 compounds also being tried, but none of them are giving a complete cure. Okay, so not like other cancers. This is a very tough area. Okay, so we compared its efficacy with sorafenib, and we found that the IC50 of, as I told, utroside B is 500 nanomolar, while that of IC50 means concentration needed for 50% inhibition, cell death. And that of sorafenib is 5.8 micromolar. That means very low concentration of utroside B is needed. So we checked these are all liver cancer. In all the liver cancer, independent of the HBV status, it was found to be almost effective. You can see utroside B is more effective than sorafenib in vitro. This is Chang liver. This is a normal cell. So we found that it is not having much activity, cytotoxicity in the Chang liver. So that means it is safe. And we compared the utroside B and sorafenib. You can see the variation. Utroside B is more potent in almost all assays. This is apoptosis. You can see here there is more apoptosis in the utroside B treated group, and all are caspase activation, etc., etc. Everything in all the studies. Then we checked whether this is pharmacologically safe. In normal mice, we found both acute and subchronic toxicity evaluation was conducted. The creatinine level, uric acid level, alkaline phosphate, everything was evaluated, and the compound was safe. This is the histopathology evaluation in the sorafenib treated group. That means actually the rule of toxicity evaluation is you have to use the IC50 concentration and 5 times higher concentration. In the case of utroside B, both IC50 and 5 times IC50 was safe. No problem was there for the animals. But in the case of sorafenib, the 10 times treated group were having severe problems. Okay, breathing problems, etc. Okay, and they were bleeding also. But the IC50 concentration was okay, not very bad also. So you can see the comparison. Okay, this is utroside B IC50 concentration, that is 500 nanomolar corresponding dose, 10 milligram per kg. Here it is 5.8 micromolar was the IC50 corresponding dose. You can see the tumor reduction. Here, utroside B is better. And we found that the compound, this is the comparison. This is tunnel assay. These are the apoptosis. It is more, and you can see the caspases tissue in the tissue of the animals. This work was published very recently, in pharmaceuticals, and we found that Actually, it was Lakshmi's work. She found that the compound is inducing apoptosis in liver cancer, but along with apoptosis, it is inducing autophagy also. Okay, you can see this dot. It's like a hole, like thing coming uh, the in the cells. Okay, so we further evaluated and we found that it is inducing the autophagy, and this autophagy is blocking its apoptosis process. That the efficacy of utroside B is actually blocking by the autophagy induced by this molecule. So we checked whether chloroquine. Chloroquine is a well-known drug used for malaria. So this we checked whether it can block the chloroquine can, if you can use as a combination, utroside B and chloroquine, when improve the efficacy. So we found that the IC50 was reduced again from 500 nanomolar to 250 nanomolar when we used chloroquine along this. So that already chloroquine is a known drug, so there is no problem with the trials and all. It is already used for the treatment, so it can improve the efficacy of the. These are different methods to evaluate the you can ask any question regarding the I am just running because I don't know how much you are exposed to these part of this caspase activation, PARP cleavage, etc. are markers of apoptosis. We checked whether it can improve the efficacy. Yeah. This is the animal experiment. We can see this is chloroquine when used. This, of course, this is not the concentration. IC50, I told you, we use always subtoxic concentration. Here also, we use subtoxic concentration of utroside B. Still, it has tumor reduction, but this is the combination. The tumor size is significantly reduced. And so we can improve the efficacy of utroside B further using autophagy inhibitors. That is the finding. Yeah, these are the different experiments just to show that all the, we can have more caspase cleavage, more apoptosis bodies as by tunnel assay, etc., etc. And we evaluated the mechanism. We are evaluating. We are not yet very clear why it is very much specific to liver cancer. We still don't know, but we found that it is downregulating several survival signals active in liver cancer signaling, uh, and upregulating some of the molecules related to autophagy. We are further working on it. These are the signaling downregulated by the compound. And we did a toxicity evaluation of chloroquine. That combination also, we found that it is very much safe. Okay, it doesn't have any toxicity. These are all toxicity evaluation results, and we recently published this work also. Okay, when you block the utroside B induced autophagy, okay, the chemotherapeutic efficacy of utroside B can further be increased. Then we checked whether, okay, the liver cancer, till now we were using the liver cancer injected tumors. Okay, we developed liver cancer in the animals. So we checked whether it can induce, one of the main reasons of liver cancer, we know one is alcohol. Alcohol can induce liver cancer, and so many women are affected by liver cancer. So the reason is one of the major reason is aflatoxin that produced in the molds growing in the rotten grains, nuts, and dried food. Okay, so this is one of the main reason for liver cancer, especially in poor countries. So we checked whether the utroside B can reverse or block the aflatoxin induced liver carcinogenesis, and this aflatoxin is classified as a group 1 human carcinogen, okay, by the International Agency of Cancer Research in Cancer. and has demonstrated carcinogens in many animal species, including rodents and human primates. So, of this much incidence, this much, is due to aflatoxin. So it is not a simple toxin. Okay, and we used DBA2J mice. Okay, in ordinary mice it will not grow, but we cannot use immunocompromised mice for carcinogenesis experiment. It should be immune. There should be immunity. Then there should be normal mice. We cannot use an immunocompromised mice for carcinogenesis experiment, or we should use normal mice. But this the strain of mice were very much uh, sensitive to the metabolites of aflatoxin. Aflatoxin is metabolized to aflatoxin B1 epoxide. This is the most potent carcinogen. So this is done by our liver enzymes. Liver enzyme of any animal. Okay, including human. So it can the aflatoxin is converted to aflatoxin epoxide. This is the most potent carcinogen. So this mice has a special ability, to toxic. It is very sensitive and it will develop liver cancer. So we gave the aflatoxin as orally, and 2 doses were given. Okay, and we can see the results. Okay, we found that the aflatoxin treated group is developing the tumor nodules, while the treated mice is not getting the tumor. Yeah, this is you can see the tumor in the aflatoxin treated group. This is the normal. It looks like a normal tumor. I'm sorry, normal liver. Okay, even the histopathology also was telling that aflatoxin. Utroside B prevent aflatoxin-induced liver carcinogenesis. This is the different proliferation markers. We can see that in the treatment group there is the tumor reduction. In the histopathology group, in the treatment group, there is tumor reduction. This AFP is an alpha fetoprotein. Okay, it is a marker for liver cancer. We can see that utroside B treated in the AFP is significantly reduced in the aflatoxin treated group. Sorry, utroside B treated group. Aflatoxin induced tumor in the utroside B reduces the development of AFP. Okay, this is utroside B treatment. This is the caspase cleavage, PARP cleavage, etc. So the utroside B treatment significantly downregulates the expression of proliferative marker, serum HCC marker. HCC, that means AFP. AFP is the serum HCC marker. Upregulates apoptotic markers in aflatoxin-induced liver carcinogenesis. So, and it also significantly inhibits the aflatoxin DNA adduct form. Actually, all these carcinogens induce cancer by binding to the DNA. So the DNA adductive formation also was significantly reduced in the utroside B treated group. Then we isolated from the aflatoxin induced liver cancer. We isolated primary cells and we found that there is a cytotoxicity and AFP adductive formation. Okay, and both in tissue and primary cells. And this was the different serious red staining for aflatoxin. We can see that it is completely blocked by utroside B. This serious staining is a marker for collagen deposition. Okay, so these type of observations shows that collagen deposition is a marker of the liver cirrhosis formation. Okay, so when you give utrocyte B to a person with cirrhosis or fibrosis, it can be blocked. Okay. Now then we checked whether this compound, this plant, can give. For example, so many people ask me whether why you gave this drug to a foreign country. They will ask plenty of money to us for the drug. Okay. They will definitely ask if they are willing to give this much money to our institute. Definitely, they will ask a good amount of the price of the drug will be very high. So, in my heart, I was feeling very sad that I could not develop this drug in India. So, what I did was actually this utrocyte was found to be highly soluble in water. Okay, so it is not like curcumin. Curcumin is insoluble in water, but utrocyte B was found to be very much soluble in water. That means if you use the leaf containing the IC50 concentration of utrocyte B, that means if to get 500 nanomolar utrocyte B, we need 200 microgram of 250 microgram of the leaves, Solanum nigrum leaves. So I compared whether that much concentration of the leaf can give the same effect of the utrocyte B. So we compared. Okay. There are some other compounds also present in this leaf, and we compared the effect, that is IC50 concentration of utrocyte B and the Solanum extract. Actually, this was found to be more effective because it contains some other molecules also. But so a person who you can see the cleavages. So that means a person who can take this leaf extract. In our place, it is grown as a weed. That means in Tamil Nadu and all, people are using it as a food additive. I mean, like chira. Okay, so if people can take it as a food by drinking or something like that, by its extract, they will get the same effect. So they don't have to buy the utrocyte B. So that's why we compared. Usually people compare the extract before doing the isolation of the compound, right? In all the thesis, you can see that first check the extract, then check the compound. Okay, isolate. But here it is, we did the reverse. We did the compound first, then we checked whether if you can, the equivalent amount of the extract, whether it will give the same effect of the compound. This is just for this reason. Okay, so we found that it is very effective. That we conducted a toxicity evaluation also. It is not toxic at all because it is used as a food additive. Okay, this is here you can use the comparison. This is the extract. This is the compound. We can see it's the same effect. Okay, so it is safe, and a person who take the equal amount of the extract will get the same effect of utrocyte. And we did the yeah, then we also so many people are very much interested, and a person came from Pune seeing our paper because he was having liver cancer, okay, hepatocellular carcinoma. He was given sorafenib. He's telling he cannot tolerate its side effects. He cannot take sorafenib, and he doesn't have any other medicine. And he was suggested liver transplantation. And he came to our lab. Actually, we had not even compared this extract, this water extract plus this animal experiment, nothing. At that time, we did not do anything, only our first paper. Okay. But he was adamant that he should get the plant. He is ready to take. He doesn't. I want to join your this toxicity evaluation. It was just a toxicity evaluation, not a clinical trial. We don't have a clinical trial. We have only toxicity evaluation. But he joined because he told I did not get a donor yet, so I want it to be tried because I have no other option. So we gave him everything. Okay. So, and he was sending, I told him 1 month later, you check your AFP. AFP level means alpha fetoprotein level. It was 60 for him. Actually, it should be less than 10. Okay. So within 15 days, I told 1 month. After 1 month, you check. But within 15 days, he checked. It became to 45. Again, after 15 months, 15 days, it came to, I think, 30 or 12 something. But after his surgery, we don't have any news from him. So we don't know what happened after his liver transplantation. There is no communication after that. And when we presented this utroside, it is a saponin. So many people have asked us whether all saponins are known to use cause hemolysis. So we checked whether our compound also induced hemolysis, but it did not. This is using normal human blood. We did not find any hemolysis. So we are doing this pharmacological safety evaluation with to one naturopathy doctor, and this is Dr. Simija Shaju, Ayurveda doctor. This is Dr. Reni MK. She is naturopathy doctor. So we cannot give the drug to patients in our trial, right? So we are doing that as a collaboration with these doctors. Okay, they are already giving this drug as a liver, drug against all liver ailments, including fatty liver, liver cancer, cirrhosis, etc. Okay, it is a medicine used by them. So we are collaborating with them for this trial. Around how many people? Yeah, to 48 subjects were recruited. And among 18 are cancer patients. So you just imagine a drug which is not even in a clinical trial, only toxicological evaluation is going on, but 18 are cancer patients. They have joined. So you have to see the need of this drug to be evaluated, because there is no medicine for liver cancer at present. Okay. So we did. You can see that none of the patients, this red is before, this blue is after. None of them had a ALP level. Okay, this is a liver enzyme. None of them had an increased enzyme level. So it is pharmacologically safe, definitely. Okay. You can see here also, everybody has. The first patient is myself. Okay, I am also a fatty liver patient. So many people. So I started first. Okay, I also got a reduction. So these are the results, and there is, of course, there is a general thought about Ayurveda and naturopathy products that, oh, you are taking Ayurveda, you are going to get kidney trouble. Okay, so I need to check the all kidney parameters, creatinine level, uric acid, everything we check. Nobody had an increase in the level. And this is AFP. This is in cancer patients. We checked the alpha fetoprotein level. We did not, so many people have a reduced AFP level. Okay. So this is a cancer marker. So our drug. This is leaf extract. Okay. We cannot give utroside V because it is already sold. Okay. Only the leaf extract we can give. And PIVK. This is another tumor marker for liver cancer. Here also there is a reduction in several people. This girl, she's Regina. She is doing the efficacy of evaluating the efficacy of this compound against fatty liver disease. Nowadays, more than liver cancer, the problem is fatty liver disease, non-alcoholic fatty liver disease. So this is NASH. Okay, so this is developing the NASH using giving high fat diet to the animals. You can see there is a significant reduction. Okay, it becomes a normal animal, a normal liver. Okay, after giving uh, the extract. Here also she is using the extract. She is evaluating the utrocyte B also in animals. Okay, you can see the uh, oil red here also. Uh, lipid accumulation. Oil red shows the lipid accumulation. You can see lipid accumulation in high fat. This is liver of the high fat diet fed animals. But when you give the extract, you see it becomes like control. Okay. This is our collagen accumulations registered again. Here also you can see in the high fat diet there is collagen accumulation, but in the case of extract, no collagen accumulation. So this is working for non-alcoholic fatty livers. Actually we are not supposed to give the picture of anybody participating uh, in the study. That is the rule. But this man, he is our security. He is adamant that the patients, without patients consent, no question of putting the. But he is telling that you put my photo, madam. Let them ask anybody come and any patient who want to participate in the study. It will be a motivation. This is his report. Okay, he was diagnosed of chronic liver disease in 2019, and he's definitely, there is usually chronic liver disease will progress to liver cirrhosis and the patient will die. That is the usual phenomenon. But he joined our study, but in 2020 it was reversed into grade 2 fatty infiltration. Now he is grade 1. You cannot, this is his report, which is now he's grade 1 fatty liver. Okay, so he's so happy. Graded fatty liver infiltration. So it is a normal condition almost. Okay, so this is a very happy thing for us. That's why he himself gave his photo to be put in the all the presentations. That's what he's telling. Yeah, I told you about Niranjan, who joined for our study for the first. It is his WhatsApp message. His alpha fetoprotein level was in the rise. Even okay. Then okay. Now within 15 days, it come from 60 to 45. Yeah, he was. Again, he sent us a 30 something like that. But uh, after his surgery, we don't know. So he was very, very happy. So we are keeping this message more than any award. Okay, it is. I am keeping this as his attestation. Okay. So this is Dr. Riel Troner. He is our collaborator from Oklahoma Medical Research Foundation. They are thinking, they for the with their help only we could get this our drug taken by this QBiomed company. Now they are looking for a clinical evaluation of this molecule. So this is my present lab. These are my PhD student, to PhD from my lab. These are these are the people who did postdoc in my lab. This is currently, this is an MK1 fellow. MK1 fellowship is a very prestigious award by the Department of Biotechnology to outstanding people. So now currently he's working. So I told you Lakshmi, where is Lakshmi? Yeah, Lakshmi started the utrocyte weaver. Jayesh started the tryptophan reamer. These are the two people identified the molecules in our compound, in our lab. New the compounds isolated in our lab. All others were bought. Okay. So yeah, this is my present lab. Kirtana and Shweta did the Sorafenib utrocyte B comparison. So now Kirtana is following the mechanism of action of utrocyte B. She is doing. Regenia is working on the non-alcoholic fatty liver disease utrocyte B's efficacy. This is Janet, my assistant, but she's the most important person in our lab. So she's organizing everything. Shabna is continuing the Jayesh's work on tryptophan, and Aishwarya, she's currently working as a postdoc in my lab on the evaluation of the breast cancer work. Like that. I think I have Devika is a technical assistant. So I think I have Sumi is my first student. I told you. Then Vinesh, chemo prevention work. Shrikant of Vinesh continued the chemo work, prevention work on curcumin. Shrikant did the continued the work of Sumi. Then we Vinod did the 5FU curcumin. He identified both the combinations with the breast cancer. 5FU curcumin and the docetaxel resveratrol. Both the combination was identified him and evaluated by Harida. All the animal experiments were done by Harida. Arun did the nano encapsulation work. He evaluated the efficacy, the improvement of the efficacy of the nano encapsulation. Okay, when the compound is nano encapsulate both in the chemo prevention and in the chemo sensitization. Meenakshi did the along with Jayesh, she did the isolation part of tryptandrin, the evaluation, I mean, and the combination with the dacarbazine. Mohan did the the efficacy of tryptandrin in non-melanoma skin cancer. I think I have covered. These were the postdocs in my lab. Thank you. Hello, anybody is there?
Yeah,
Everybody?
ma'am. Everybody is there. Everybody is there. Yeah.
Because I can't see, I am seeing only my slide. Okay, so I think
Okay.
we can. Yeah, but don't stop sharing because if somebody has a question. Yeah,
Okay, thank you, ma'am, for your interesting address. Now, I welcome Ms. Rajeshwari R. Menon, Research Scholar, Department of Commerce, for proposing vote of thanks.
no question. Nobody has any doubt. Nobody has any doubt. If there is no question, means either everybody understood everything or nobody understood anything. So I don't think everybody understood everything. So I expect some questions, right?
There is a doubt, ma'am. Please
Yeah.
wait. Hi, ma'am.
Hi.
Is it audible?
Yeah.
So, as you said, these methods are used to reduce the size. After the size, it has been reduced. What is the next procedure we are using it?
Reduce the
As you said, these methods are used to reduce the size of the tumor.
size of what? Size of the tube. Yeah.
Is it malignant or benign?
It is malignant. All are liver cancer. We inject the liver cancer cells to the animals. Okay. So maybe within 15 days the tumor will develop. Okay. So there are two groups. One is a group, the group of animals given only the tumor injection, along with we give them normal diet and the vehicle. Vehicle means the solvent used for the drug. Okay. And the other group, we give the drug. In both cases, we inject the animals with the tumor. Then after 15 days, we start the drug treatment.
If it is used in humans or not? Humans, have you?
How can I do? They will, I will be sued, right? I'm a scientist. I'm not a doctor. It should be done clinical trial. That's why we were giving to the, with the collaboration of the naturopathy and Ayurveda doctor, that leaf extract is being given to human trial just for a toxicological evaluation. But since there are no other drug available, these patients are also taking it. And I showed you the results, right? They are getting a very good reduction for their tumor markers. Did you understand?
Okay.
No?
Yeah, ma'am, I understood.
Yeah. We cannot give drug. Okay, I cannot do that. Only the doctors can give.
Yes, ma'am. I wonder doubt that is any role of tumor suppressor genes like P51 and P21?
Yeah, definitely it will be. Yeah, there will be. Yeah, we are. I told you the mechanism we are evaluating. Okay, so definitely there will be molecules down regulation, but the that are general. If it is just because of tumor P53, in all tumors it should have same effect, right?
Yeah.
But here it is liver cancer. So definitely there will be downregulation of almost all the survival signals and upregulation of the tumor suppressors. But
Okay.
why specific to liver? That's
Yeah.
why that is what we are evaluating currently.
Okay. Okay.
Definitely it may be.
After
Okay.
the size is reduced, what is the next step?
Ma'am, after reducing of the size, what is the next procedure for that? Like we are removing removing.
Definitely in the case of liver, there is if there is a cancer, they will do the surgery.
Yeah.
Okay, in now this is animal model. Okay,
Yeah.
that we are yeah, it is time bound study because it after injection 30 days you kill the animal.
Yes.
Okay, it's not continue. Maybe if you give continuously, maybe it will be completely gone also because I told you out of the 10 animals, only 4 developed the tumor, others did not develop tumor at all. So if you continue, maybe all will go, but we get clearance for 1 month study.
Okay.
Okay, so we take, but in the case of human studies, we don't kill the man, right?
Yeah.
So it will reduce, I think. It should.
Thank you.
Yeah. In clinical trials, yeah.
Yeah. Oh, yes.
Yeah, we cannot do anything. Yeah.
Okay. Thank you.
What is your opinion about Jayed sir? You did not tell anything about Jayed sir. How is he? Because I have given you one of my best students, and I am very sad that he is not doing cancer research at present. But if you people are happy, I am also happy.
Okay, ma'am.
Yeah.
Thank you for your lecture. Now I invite Rajeshwari Armenan, Research Scholar of Commerce Department, for vote of thanks. Gratitude is one of the least articulate of emotions, especially when it is deep. Good evening, one and all. We have reached an end to the most innovative lecture sessions organized by Institutions Innovation Council of St. Thomas College, Pala. Today, I take this opportunity to put my gratitude into words. First of all, I thank Dr. Ruby John Anto for the informative talk that she has rendered on patenting of innovation, bioprospecting for novel innovations to improve cancer therapeutics. Ma'am, you have enlightened us by your invention and also given us information about various topics like steps in chemo prevention, chemo sensitization, chemo resistance, and how various plants like curcumin and other medicinal plants can be used to control cancer. Words would fall short to express our thanks to you. On behalf of IIC and entire fraternity of St. Thomas College, Pala, I extend my earnest gratitude to you, ma'am. Thank you, ma'am.
Jayesh, 1 second. 1 second. Jayesh, can you? Hello?
Yes, ma'am. Yes, ma'am.
Yeah,
I'm here.
yeah, yeah. Because I just wanted to have a picture with you. Why don't you join? One
Okay,
second.
ma'am. Okay. You can take.
Next, I would like to thank our principal, Reverend Father Dr. James John Mangalat, for being a strong pillar of support, a guiding light, and an encouragement for all the events we organize. Thank you, Father, for your ceaseless support. Education is far more than that happen inside the four walls of a classroom. We are very fortunate to have teachers who have recognized this. I extend my sincere thanks to the President of IIC, Dr. Sajiv Martin, and Coordinator, Dr. Tejal Thomas. I also thank Dr. Jayesh Antony and Dr. Joby Matthew, who graced this occasion in spite of their busy schedule. I also thank all the resource persons who have joined us and who are well known for the contribution in their respective fields in this two-day Impact Lecture series of IIC St. Thomas College, Pala. A big thank you to Suresh sir and Gauri, who remained a part and parcel of the event. I also thank Mr. Joel for giving us all the technical support for making this program a huge success. The essence of fruit is always tested the last, and I believe last is the best. Last but not the least, I also thank all the students for their participation, who by their participation made this event a huge success. I'm sure that each one of you have got a spark to light a fire inside you. Once again, I thank all of you. Thank you. Thanks a lot.
Okay,